I could tell you real quick what we know about grain shattering in hemp. That's absolutely nothing from the genetic standpoint. So I'm going to kind of go a little more into what we're actually finding as the sources of problems behind this and how we could change this to improve yield and what that potential yield could be. So as many of you may know, just give a bit of background, hemp has been grown for at least 8 millennia. And historically in Kentucky, it was first planted around Danville in 1775. From that time up into the 1870s, hemp was primarily grown as a fiber crop, mostly for rope production. It was after the 1870s, up until the end of the last crop of industrial hemp produced in the U.S., which was in Wisconsin, that production moved west and north, and at that point, Kentucky was primarily a supplier of hemp seed to be grown in other states. And so when it comes to hemp seed, there's various uses, and we've kind of already covered this. There's raw seeds, there's the oil, and then there's the hemp meal. And instead of going into all of what it could be used for, so basically I combined a love of Kentucky basketball with hemp, and what we get here, as well as good food, and what we get here is a bracket where you try different foods and compare them, and then eventually you'll wind up with your favorite here. And so this is just to try to get you more interested in the food potential of this crop, because right now this is primarily where it's at, since we can't really use animal foods. And you can already go ahead and fill out some of them, because I made sure to include the ones in the top left corner there as what we had for lunch today. Going on though, as far as seed shattering, hemp is an unusual crop. It's been cultivated around the world for millennia, but unlike other crops, it's only been partially domesticated. So you can kind of think of this as like your pet cat. It stays at home with you, wanders around, but at the same time, it doesn't mind going outside and killing whatever it could find, because it could take care of itself. Hemp has this ability because one of the crop or traits that have been domesticated out of all our other crops is this trait called shattering, and that's where the seeds fall off the mother plant. So corn, soybeans, wheat, they don't do this, but hemp does, and this could cause a serious loss of grain as it shatters from the seed head throughout the season. Despite that, up in Canada and other places, we could still get 800 to 1,000 plus pounds of grain per acre under good conditions with this shattering trait. So what does this shattering look like in hemp? Well, any of you that have grown it, you've probably noticed that you have some of these little papery bract type things hanging around the plant. That's actually where the bract that holds the seed onto the plant has opened up, exposed the seed so it could fall off the plant. And then what you get is when wind or something else comes along, it falls onto the ground and establishes seeds in the ground for the next season so it can propagate itself. If you get rid of shattering in fully domesticated crop, this doesn't happen, and that's why you don't see wild corn plants or wild soybean plants, because they're not readily shattering seeds into the ground for the coming season. So what can we do to limit this yield loss from shattering? First, it helps to know a little bit about how grain matures in hemp. And basically you have an indeterminate fluorescence. All that means is you have a flower or a flower spike that keeps flowering as it grows up until the point the plant has enough seeds that it doesn't think it needs to keep growing anymore. That translates into, at some point, you get seeds starting to ripen in the lower part of the plant and immature seeds at the top of the plant. And so right now it's recommended by growers up in Canada that you harvest around 70% maturity, because then that should minimize the amount of seed being lost to the ground from shattering and hopefully minimize the amount of immature seed in the seed head. At some point eventually though, if you leave it too long in the field, you'll reach 100% maturity where the grain head's completely dried, dead, and the seeds all are shattered out of it. So what's this translate into yield? Well, in the conventional case with shattering, what you have is, these are hypothetical curves, not actual data, but what you see is you wind up with a curve where it ramps up until a certain point, and then the seeds start to really shatter out of the head and the yield starts going back down. And so currently this is about 70%, we think this is at about 70% based on what Canada does. But if we could get rid of this shattering trait, what would happen is we could keep that curve going up and reach a much higher maximum yield. And so this could be the potential maximum yield for the crop. And so this is one thing we hope to figure out. Things that contribute to this shattering in the plant are there's several direct causes. Things such as weather. So this past year we had a lot of wind, a lot of rain. That could physically knock the seeds loose from the grain head of the plant just by the plant moving and the rain hitting the seeds. You also get a direct loss on the mechanical end. So when you go to the combine, if you're using a paddle head on the combine, as that paddle comes down over the grain, you're inadvertently knocking some seed loose off the plant that's poorly attached. As well as there's what I call bird perching losses. So this is where we have a problem with birds on two levels. One, the birds like to eat the seeds, but the second is the birds landing on the plants move and bounce around the stalks of the plants, causing the seeds to fall out as the plant moves and they're moving around. Indirectly, the shattering causes a loss of yield because you're having to harvest immature seed. You also are going to wind up with, a lot of times wind up with a very heterogeneous crop. The crop's not uniform. Some of this is genetics. Some of this is other planting parameters. But when you have this, you have some plants like this one that may be like 25% mature in the field, and you have other ones beside it that may be 90% mature. And so it makes, in addition to causing yield loss, it makes it difficult to determine when's the optimal time to harvest. And additionally, since you have more immature seeds that aren't being harvested due to shattering, you're going to have some seeds going through the combine. And now you're having to separate out immature seeds from mature seeds through the combine instead of setting the combine parameters just to collect all the seeds. And so I'm going to touch on each of these topics and data that we've collected to illustrate each one of them. So the long-term goal of our lab is basically very generic: study hemp biology, chemistry, physiology. So I kind of work with all the different aspects of hemp, particularly the phytocannabinoids and the grain. But for this particular project, we're going to specifically look at identifying losses due to harvest of immature seeds, this natural shattering due to birds and weather, shattering caused by mechanical purposes such as the combine, as well as the losses due to the immature seeds being thrown out the back of the combine. And eventually what we want to do is identify or generate genetic sources for shattering resistance in this crop and fully domesticate it to reduce these yield losses, and which you'll see can be substantial. So the first part is we'll just cover mature seeds and immature seeds. This is what happens if you collect some seeds and you just divide them out of what you're picking off the head. You wind up with these real pale seeds that are immature, ones that are a light brown color that are kind of transitional, and versus a dark brown mature hemp seed. When you dissect these, what you find is these immature seeds have basically no embryo development in them, and so they're very lightweight. And so these coats, because it's basically just a seed coat, is only half of the mature seed, half the weight of the mature seed that you would see here. If we harvest at that recommended 70%, that means 30% of our seed is immature in this category. And if that 30% only weighs half of the mature seed, if you're collecting it, that's not even if it's being completely lost, you have at least a 15% yield of your crop weight of your crop being lost due to this one trait of not having fully mature seeds throughout the seed head. Using numbers from 2015, the values for Canada on the prices of seeds, conventional was 75 cents a pound, organic was $1.15. So that translates into $112 to $173 loss per acre for this one factor. The rest of this data was collected using a simple tray put out in the fields and measuring things and just seeing how much seed landed in it per area. And what we find here is when I did this over a weekend, 3-day weekend, right before harvest, it calculated out that there was about 76.7 pounds of seed lost per day at this point in time. So that's an estimated over a 30-day maturity for the grain to ripen. That could be 1,400 pounds of seed that could be lost over the cycle. Now that's a caveat because this was close to maturity at the time. We know that's not going to be a linear response, so it's probably at the high end of loss at that time, and it had stormed recently. So realistically, we're probably still somewhere in half that value, though, of 350 to 700 pounds of seed being lost per acre over the growing season of this crop. And that could be anywhere from $260 to $805 per acre being lost because of this trait of seed shattering. We're also losing some on the mechanical end. When we put out a tray, Patrick and Cameron, I worked with them one day when we were harvesting some plots, and all we did was put out the tray before they run the combine completely over it, and we found that once the head just passes it, you wind and the seed lands in the tray. We were almost at the exact 70% maturity, which was recommended harvest, based on the number of mature and immature seeds landing in the tray, and that was we're losing 34.6 pounds of seed per acre. We thought we had the combine, or they thought they had the combine maximized, pretty efficient to collect most of the seeds. But we're still losing quite a bit. So that's another $26 to $40 that could be lost per acre. And so we shouldn't have this trait if we could eliminate shattering out of this crop. On the other end, the stuff that was flowing out of the back of the combine, because you have to try to separate the immature seeds from the mature seeds during harvest, you get a different set of losses. So in this case, we put the trays behind the combine once it went over the plot. We found that there wasn't enrichment for immature seeds being thrown out the back of the combine. There was still a high weight of mature seeds. And so out of the mature seeds, this was 39.8 pounds of seed per acre, which is another $30 to $46 being lost per acre being thrown out the back of the combine. And so there definitely could be continued methods for optimizing combine settings to reduce this somewhat. So this summarizes all that data that I just went through. Basically, if we could reduce or eliminate shattering, we could really improve yield for this crop. We could improve anywhere 350 to 700 acres for just the shattering, natural shattering, 40 pounds an acre for mechanical harvesting, another 34 or so pounds per acre for stuff coming out the back of the combine, and then immature seeds maybe 150 pounds an acre. So potentially we could save anywhere from 574 to 924 pounds of grain per acre we could actually harvest if we could get rid of this one particular trait. Based on these plots still yielding 600 pounds of seed per acre, which was pretty low, that puts a potential production estimate upwards of 1,500 pounds an acre for this crop, probably closer to 2,000 pounds an acre if we could get this one trait eliminated. And so that could be anywhere from $430 to $693 an acre for conventional grain, or $660 to $1,063 per acre for organic grain. That's quite a bit of money, if you ask me. So based on this, we could come up with some recommendations for ways to try to mitigate this loss currently until we can get a variety developed that's non-shattering. There's supposedly one variety out on the market that anecdotally may be reduced shattering, and that's something that we want to look into. But variety selection is going to be important. We want to figure out which varieties are more or less susceptible to this trait. So far though, we could increase crop uniformity. So if you get a good germination, a variety with higher genetic uniformity, and using recommended planting and get a good stand, you shouldn't have that crop heterogeneity and get a more uniform crop. I recommend avoid planting hemp fields by forested or bird roosting areas because that's going to minimize the amount of birds landing in the field, which can knock that grain loose. And I think that was one of our biggest factors for what was lost up at the UK farm at Spindletop. Was not so much the birds eating all the grain, but the birds knocking the grain loose. As far as determining, it can be difficult to determine the optimal maturity, particularly trying to shoot for that 70%. So an option there would be to hand thrash a couple seed heads over a container and actually just count the seeds like we did to figure out that optimal harvest time. Once you get close to that though, that 70% maturity, which is suggested to shoot for until we can find other research that may suggest otherwise. If it's a lot of rain coming up or a heavy windstorm, it may be important to consider possibly harvesting a little on the earlier side to reduce the amount of loss compared to just waiting till after that storm because of the amount of grain that could shatter out of the seed heads from the elements. The other thing is to make sure the combine's set correctly and trying to kick out only immature seeds. I would recommend doing test passes in the field to optimize the seed collection. And then while driving the combine, to avoid that mechanical shattering, try to go slow so you're not hitting that paddle wheel real hard against the grain heads. So all this leads into what we're hoping to accomplish, and this is the only slide I have for future work. But we're working with Atalo. We want to do with this EMS mutagenesis. So basically what this is, it's a traditional plant breeding method where you can mutate and generate a lot of genetic diversity within the crop. And then we'll screen that and we're going to look for no or reduced shattering mutants in there, which then can be bred into conventional commercial varieties. The other part we're going to do this year is identify varieties with reduced losses from shattering. We're going to just take advantage of the ongoing variety trials and see the losses in those different varieties over time and see which ones may or may not be more susceptible to this trait. We can also use that data to figure out the potential maximum yields on this for this crop. So that's all I have. I'd like to thank KDA. Without this work, a lot of this would not be possible. My advisor, KDRDC, which is where I work, all the guys from Altalo and my lab members. And just a quick plug, for anybody interested, you're asking about sources of information. Somebody was asking about sources of information earlier. I have a Facebook page called American Hemp Growers Society where I publish anything we publish at UK or other places publish from their departments of agriculture, as well as any ongoing legal stuff. And it's really a forum for growers to discuss with other growers ways to optimize production of their crop or anything of interest to them. So,
thanks, Craig.